Welcome to Pre-Algebra with Miss Betsy. Today we are continuing our discussion of geometry. We're going to be talking about intersecting lines and the angles that are formed at the intersection of those lines and the relationships between them. Before we get started though, I thought a geometry joke would be a good one. Why was the sailor afraid of geometry? Because he had heard that the Bermuda Triangle makes you disappear. So I've got our sketch on the board already. If you're using the same text that I am, I'm in section 11.3. It's called Intersecting Lines. I'm on page 358. I'm using Pre-Algebra for Christian Schools. It's published by Bob Jones University Press, first edition. Okay, we have lines. Two lines here and they're crossing only at one point. And there is no way that you can have a straight line that crosses at more than one point. But two lines that cross at only one point, these actually have a very logical name to them. They are called intersecting lines. Isn't that nice to have a definition of something that actually makes somewhat sense to us? When you have two lines that intersect, you have four angles that are formed. It's like you have two roads that cross. When you're driving down the road, you come to a cross street and you've got four different places that you can go. Four different angles that are right here. And what happens is you have two pairs of angles that have a specific relationship to one another. And the adjacent angles are next to one another. Vertical angles are opposite one another. So we could say that angle 2 and angle 4 are not adjacent. Let's do angle 4 and angle 1 would be adjacent, but let's just sort of start counting with number 1. Angle 1 and angle 2 are adjacent. Angle 1 and angle 3 are vertical. Angle 1 and angle 3 are vertical. Vertical angles are right across from each other. We've got a vague memory of years ago we would call vertical angles opposite. They're opposite from one another. So is there another pair of vertical angles besides 1 and 3? Well, yeah. Angle 2 and angle 4 are also vertical angles. Well, what about adjacent angles? How many pairs of adjacent angles are there? Well, angle 1 and angle 2 are right next to each other. What about angle 2 and angle 3? What else? Angle 3 and angle 4? What else? Angle 4 and angle 1? Now, what we talked about last time, we talked about supplementary angles. We talked about complementary angles. We learned that complementary angles were two angles whose sum was equal to 90 degrees. Now, in order to know that angles, that you got a 90-degree angle, remember we said we had to show that little box, that little square in there that defined that angle to be a right angle. We don't have any boxes here, so we don't have any right angles. So we're not going to be able to do anything about complementary angles. However, supplementary angles are two angles that form a straight line. Okay? What do you see here? Adjacent angles, they're on a line, aren't they? So adjacent angles are always supplementary, and that's a piece of information that is very, very important to have, to get down. Adjacent angles are always supplementary. And that's a very nice piece of information to have when we're trying to calculate the measure of angles, because that tells me that if I know the measure of one angle, let's make this one up, this angle right here measure is 110. Angle 1 of 110 plus angle 2 has to be equal to 180. So you do your easy pre-algebra. If angle 1 is 110, angle 2 has to be 70 degrees. So we're going to use that relationship constantly when we're working with geometry. We're going to go ahead now, since we talked about adjacent angles and vertical angles, we're going to change these angle numbers here so that I'm matching up exactly with what your example is on your book on page 358. 3, 4, 5, and 6. And angle 6 is 50 degrees. Okay? They want us to answer some pieces of information here. What it says is, without measuring, find the measures of angle 3, angle 4, and angle 5. Find the measure of angle 3, measure of angle 4, and the measure of angle 5. How can we do that? We only know what one of those angles is equal to. Well, we have several pieces of information that we can use. We have vertical angles. What do we know about vertical angles? Vertical angles are opposite one another. So we can say angle 5 and angle 6 are vertical. Do you agree with that? They're opposite from each other. What do we know about vertical angles? Vertical angles have the same measure. Vertical angles have the same measure. So how does that help us? Well, we already know the measure of angle 6. Angle 5 is vertical, so the measure of angle 5 has to be 50 degrees also, correct? Now, what else do we know? Well, we know that angle 3 and angle 6 are supplementary, aren't they? What does it mean for angles to be supplementary? It means that they're on a straight line, that they're supplementary. It means that I can't spell this morning, supplementary. So the sum of those two angles is 180 degrees, isn't it? So angle 3 plus angle 6, the measure of angle 6 is 50 degrees. That has to be equal to 180 degrees. So the measure of angle 3, once you subtract your 50 from both sides of the equation, you now know the measure of angle 3 is 130 degrees. Measure of angle 3 is 130 degrees. Measure of angle 5 was 50 degrees, wasn't it? Now, what is the measure of angle 4 going to be, and how are we going to figure that out? We can figure that out two totally separate ways, both equally legitimate. We can see that angle 3 and angle 4 are vertical angles, so they're going to have the same measure, aren't they? What's their measure? It's 130 degrees. What was another way that we could have figured out that this was 130 degrees? If we forgot about the fact that vertical angles have the same degree? Well, we could also see, we've got a straight line here, so angle 6 and angle 4 are supplementary. That means the measure of these two angles has to be 180. 50 plus x is equal to 180. You solve, and you end up with the measure of this angle, again, being equal to 130 degrees. And these are the relationships that are going to take place between angles when you have intersecting lines. You're going to use constantly the fact that you have vertical angles, you have adjacent angles, which are angles right next to each other. You have the sum of the measure of two angles that are supplementary, like a straight line is always going to equal 180 degrees. The sum of the measure of two angles that form a right angle, that sum is always going to be equal to 90 degrees. So just be reviewing these vocabulary words and these concepts until you have them in your head and you are totally, completely comfortable with them. There's one more type of line that we want to talk about. If you just have intersecting lines, you know that you have a relationship that exists between the angles. You can also have two intersecting lines that are parallel. And I did not mean to say parallel, I meant to say they are perpendicular. Perpendicular lines are lines that perpendicular. They are lines that intersect at a right angle. And a perfect example of two perpendicular lines is your y-axis and your x-axis on your Cartesian coordinate system. We have this little square here that tells us that these angles, these two lines, intersect at right angles, that they are perpendicular to one another. And there's a little bit of vocabulary that we want to have here. Notation. Let's go ahead and do this the same way they do. We have point A, point B, point C, and point D. These lines are perpendicular to one another. So we would say that line AB, don't forget the arrowheads, is perpendicular to line CD. Line AB is perpendicular to line CD. Let me write this out to you. Line AB is perpendicular to line CD. If I were just speaking this notation right here, line AB is perpendicular to line CD. And if you have a 90-degree angle in one of those corners, every other one of those angles has to be a 90-degree angle as well. And we know that to be true because we know that when you have when you have intersecting lines, you have adjacent angles. So we have this angle right here is adjacent to the first one. If that's 90 degrees, this has to be 90 degrees because they're supplementary. Or you could also simply go on the fact that when you have two intersecting lines, vertical angles have the same measure. So when you have perpendicular lines, you have four right angles. All of those angles measure 90 degrees exactly. Go ahead and get your vocabulary list out. Review what you've done in section 11.1 and 11.2. Add some new vocabulary to this and go ahead and get your work done. It's not hard, but you gotta put some time into it. See you next time.